Okay, I think that we are going to start. The idea of this evening session is that we are going to use part of the session now at the beginning to go through the area of the exercise and to solve some of the questions that you have been asking in the chat about how to recognize some structures. If you have doubts or more questions, please put them in the chat and we can resolve them during this 90 minutes period of this task exercise. So the materials that we are going to use for this evening session are the ones that you have downloaded. I remind you that what I showed you this morning was the global Magellan mosaic that you can also download from USGS. I checked, it's a 22 gigabyte file, so it's big, but okay, with more or less effort, is handled without problems by QGIS and the rest of the GIS programs that you may use. And it's good because you have all the planet to explore, but the way on which we really work is when we have clear the area that we want to study, we just ask for the mosaic or download the images of that part of the planet. So we have a smaller area, a smaller file size, and it's easier to work with. So we are going to work now with the project that you have and that you have downloaded, and I imagine that you have in your desktops. It's not necessary for you to follow what I am doing. It's not really hands-on that you have to repeat everything that I do. You can go around, look. The idea is, again, to see examples of structures, of materials, for you to be able to recognize them once you sit down in your office or house and do the exercise. Okay, I'm going to share the screen now. Just share the screen. And as you can see, I have the same project that you have for working. Before to start having a look at different structures, just a couple of things. You see a lot of files here. We try to provide you with all the possible data that you could have to study a region, but you are going to find out that in many occasions, the quality of the data is not very good for certain areas. So for example, you have here, the main file is the left-looking radar image. So remember, everything that we are looking in this image is illuminated from the left. It's important to be able to recognize and to describe features. But in this area, we have also a partial coverage of right-looking image, that if you remember the global map that I saw you before, is not as complete as the left-looking one. But okay, if you are lucky and your area of study has both coverages, it's always going to be good. In this case, this is the coverage that we have for the area in right-looking radar images. You see that it's not covering the whole mapping area and it's stripped. This is because when the Magellan probe that was going in a north to south orbit, taking data, sometimes experience problems with energy, and these data gaps are related to this lack of energy and was not imaging at that moment. So we only have a small part of the area with right looking, but it's also interesting for you to have it in case you want to experience and you want to see how things are looking if you illuminate from the opposite part of the image. You also have all the different ancillary data that you can extract from the Magellan radiometer and altimeter. You have here a map of the slopes, but topography of the Magellan image, of Magellan proof is not the best that we can have is one data each 5 kilometers. The resolution is not very good. The real jump that we are going to have when the next missions go to explore Venus are the increase in resolution of the topography and the access to surface composition by the instruments that Giulia described before. I think that radar images are going to be great. We are going to increase our resolution of radar images, but the real quantum leap that we are going to have is the better quality of the topography and the access to surface composition of the whole surface. For those of you who are familiarized with other planets, imagine you can remember what the MOLA topographic data mean at the moment to the study of Mars. That's what we are going to have when these new missions go to Venus and provide us with better topographic data. We also give you a layer with the Fresnel reflectivity, also from Magellan, that you can have a look if you need information about these layers, and they are in the web page where you can download, and there are papers that describe the nature of the data and interpretation of the data. We can give you references if you are interested in those. We have the topography that we can use, but as I just said, it's not the best. And then we have the different VIRTIS layers that Giulia described before and that you are going to use to extract the composition, because it's really one of the reasons why we choose this part of the planet, because of the coverage and the quality of the VIRTIS data. So we are going back to the real good mosaic, the left looking mosaic. And another thing that I wanted to show you is, if you remember my presentation on the data, I showed you at the end that if you invert the images, you in some way are able to better see the lineaments on the image. I am going to show you this because in my experience, when you are doing structural mapping, remember that you are going to invert, so you are going to lose the information of the reflectivity that I told you, that I described you before in terms of darks and brights. But when we invert the image, what we are going to do is to have the lineaments, the electronic lineaments, darker. And my experience doing structural maps is that at the end of the day, when you are doing these structural maps, it's easier for the eye to recognize structures in this other format. So I suggest you to try. Maybe it doesn't work for you, but for me, at the end of the day, as I said, it results very useful when you are doing a structural mapping. So to do this, you only have to go to the layer, go to properties, and when here you have black to white, you just change from white to black, apply, and you have the inverted image. And as you can see, what do you have here are the tectonic lineaments in dark over a more bright background. As I said, I found myself this format very, very useful when you are doing tectonic mapping. But remember, you are not going to apply the same principles to describe the reflectivity of the surface because you have inverted the image. We are going to go back to the previous and the real appearance of the image. So we have here the left-looking radar image of the area. I had a doubt in the chat before. Someone asked me about that if I could go back to describe how to recognize wrinkled ridges from fractures in these kind of images. Well, one thing that I have to tell you is that sometimes it's not easy. I've been looking at these images for 20 years, and still it's hard for me sometimes to recognize some structures because the illumination, the orientation of the fractures with respect to radar, and many factors that can affect how you see a structure. So don't worry if you don't recognize initially everything, because it's hard. And even with experience, sometimes you have a lot of doubts recognizing some of the structures. In this working area that you have, we are going to have a look at this part of the image. And here we have examples of both types of structures, of wrinkle ridges and structures. Remember what I told you about the way that the radar interacts with the structures, if they are positive or negative topography features. What we have here, these structures are the wrinkle ridges. How do you recognize the wrinkle ridges? First, if you are lucky and you see clearly the topographic nature of the feature, you see that you have a bright surface and a darker one. You identify them as a positive relief feature. That's a crest, that's a ridge. So in this way is one way you can recognize them. But probably the easiest way for you to recognize the wrinkle ridges is the term wrinkle. The trace of these wrinkle ridges, as you can see, is very sinuous. It makes wrinkles. It's not just that they are positive topography. They have positive topography. It's their wrinkle nature that define them. And that they are never alone. They are in families. You have a lava plain. The lava plain is subject of contraction, and you have these wrinkles, these ridges that deforms great areas, and that they have very constant strikes. They have very constant directions in all the regional extent of the areas. So if you recognize one of the wrinkle ridges, and as this one has this trend, if you see parallel structures with the same wrinkle appearance, you can interpret them as wrinkle ridges. Just together with this, you see these other lineaments that if you see them, you can easily see that they are very straight. They don't have the wrinkle appearance. We can make zoom on this, but you're going to see that it's very hard to distinguish nothing more than a single lineament, very straight lineament. We interpret these ones as fractures. And it's an interpretation based on experience, based on that we have seen them in many parts of the planet, and based also that in some parts we see transitions from graben to these single lineaments, and we interpret them as extensional features. But the main difference in this part of the planet, and in general in all the planet, for you to distinguish the wrinkle ridges from the fractures, is going to be this difference, this sinuous appearance of the wrinkle ridge versus this very straight trace of the fractures. These fractures normally are long, straight, and as you can see, they go for many, many kilometers. And you can normally see them also in families, but they are not as constant in trace and spacing as the wrinkle ridges. So I don't know if with this explanation is enough for the question that was before in the chat. In any case, if you have further doubts about this, we have an hour and a half to solve them. So what we are going to do now is just to go around a bit on the area, just describing you what you are seeing in the context of what we have said before. If you remember the geological context, we were in the transition between Parga Chasma, that was to the northwest, to the northeast, sorry. We have it around here, these long, very long fracture systems with Lotus Coroni, and we have here Ellen Planitia, the lava plains. So this part of the study area belongs to the plains, and the structures that we are going to see are the ones that normally characterize the plains: the ridges, fractures, smooth surfaces, different textures, but you don't have really pervasive fracture systems. And in this part of the of the study area, we have more a style more related to the deformation in Parga-Kazma. You see that there are many fractures. You see the, sorry, I was going to focus. You see all these structures. The deformation is more pervasive and is more related to what you can find in these fracture systems. Okay. Another thing that is interesting for you to see in this study area, as I said before, is that we have different types of impact craters, different types of volcanoes, and different types of terrains. There were also I remember now that someone asked me before in the chat the difference between a step-side dome and a crater. I'm going to make a little spoiler here, but I think that is good for the sake of the clarity of the mapping, is that here in the south, you have an example of an impact crater, an example of a steep-side dome. These two are features with names. If you are interested, remember that you know where to get the names of the features. This is Abeoma Mons, and I can't remember the name of this crater. But if you compare both, you see how the crater has the rim and the inner low, in this case, with smooth materials. It's a crater that is partially filled with lavas. And if you see the step-side dome, you see that we have a flat top, and then we have the steep slopes that characterize these step-side domes. If we put the topography, these features are big enough to be resolved with topography. If we have here the topography, if we put the topography, we see very clear that the step-side dome is a feature with a positive topography, but the crater is a low. So this is the way we can distinguish these impact craters from these step-side domes. Besides, you see that radiating from this step-side dome, you see some lava flows. Normally, you don't see lava flows around impact craters, although as Lucia saw before, some craters present some fluidized associated flows. Okay. More things. You see that we have here some zones with a clear high topography. You are going to see that there is a relationship with the VIRTIS emissivity on this. So now Giulia probably is going to give you also a couple of hints about to face the mapping on this area. The important thing, as I said before, is not for you to make a thorough and complete geologic map. It's the first time that you're going to use radar images, and it's hard. The goal that we have for this exercise is for you to recognize different types of structures, to map structures, to recognize at least a few units in terms of the radar properties, and that you identify clear things like lava flows and junk features on the area, so you can establish some kind of like a very not complete, but like a geologic history. What is older here? What is younger here? As I said before, this is an area of the planet where we think geology is active now. We have active tectonics and active volcanism. So you are going to find very interesting to compare the different volcanic features and tectonic features that you have here in the area. Okay. I don't know, Giulia, if you want to say something about the VIRTIS data here.
Yes, I can add just a few words showing a bit QGIS, but then they can start with the exercise. Yes.
Okay, so I pass you the. Well, I stopped sharing, so I guess that you can share your screen now. I will be checking the chat to see for questions. So again, if you have doubts, just put them.
Okay, so just very shortly, so that then you're free to start the exercise. So if you go back again to the scaled emissivity values, and if you have problem to scale the values, you can ask me in the chat. We can go through that together again. But you have all the points listed in the text guide that you have also. So as Ivan was saying, we don't want a really super detailed map. What we want you to do is to link the main features that you're going to recognize, the main geological features, with the anomalies in the emissivity that you see in this data. For example, here in green, you see these whole green pixels. Those are high emissivity values, and those follow the topographic trend of the Magellan data. If you want to visualize this better, you can just go here to properties and then in legend, and you can have an opacity slider. You click here. You make sure that it appears in the other side of this window. You click apply and OK. And like reducing with this opacity layer, you will be able to overlap the VIRTIS to see at the same time VIRTIS and Magellan data, and this might help you in the mapping procedure. I think this is all that I have. So you have all these pixels of high emissivity in these two regions, and once again here below, and this is matches well the topography below. And yeah, I can stop sharing, so then you can start the exercise, and if you have questions, I'm here to answer with Ivan.
Okay, the idea is for you to start going through the area and start the exercise because we are going to be here for you the whole hour. After this, if you have doubts, it will be harder for us to answer asynchronously. We are going to check the chat, but it's not going to be as continuous as now. So the idea is that you start going around, try to recognize things, play with them, with VIRTIS data, with the image data, and please ask all the doubts that you have. Just before I forgot, one more last thing is that remember that Ricardo told you in the first day of class that you could put the symbology for planetary mapping. I don't know if you remember and you remember how to do it, but to map, if you remember the first day of class, if you load the information on planetary symbology, you have here the symbols for not just contacts, but if you go through these symbols, you have for normal faults, strike slip faults. But as you can see, we have also pictures for example, partially buried fractures, gravens, and there are even some structures that are particular to Venus. I see that, for example, you have the symbols for ribbons that are those graben that are present in tessera terrain. You have wrinkled ridges. You have, for example, corona and nullus. You have symbols that are specific for the things that we are looking at Venus. So it's important for us, when in the moment that we are going to review your work, that if you use this symbology, it's very important because it will be homogeneous to all of the exercises, and it will result easier for us to recognize that you have recognize the different structures. So I don't know if you remember how to do this, but if you don't, I'm sorry. To load this symbology, you have to go to, I lost the symbol now. You have to go to the post plugins. Once you have the plugins, okay, now you have to load here the, okay, where is now? Okay. Okay, start working and I'm going to know for sure what it is. In 5 minutes, I remind you how to load these planetary symbols for sure, okay? We will be checking the chat for doubts. Okay, I have it now. So just for a second, I'm going to screen share. Okay, you have here this button that loads the processing tools. If you go to the Mappy plugin, in mapping, you have auto download at setup mapping symbology. If you do this, you're going to load these symbols into your QGIS, and you can use the different symbols that I have just showed you. So as I said, it's important that you use the standard symbology so we can review the different projects and they are homogeneous and we cannot have to guess what kind of structures do you map, okay? Okay, with this, I stop sharing and I pass to control the chat room and to be ready for your questions. Okay, there is a question in the chat about mapping of Corona. Namiska asked if we have to mark the total area of the Corona of each lineaments in the structure. Okay, it's not necessary to map every lineament because you are going to see that in some coronas, the annulus is really composed of pervasive deformation, where the structures are really close one to each other. So at the scale of mapping that we are doing here is not necessary to map all the structures. So the important thing is that you see the trends and that you differentiate the ones. What we are going to map in a corona, if we see that there are clear lava flows that emanate from the corona, or we see clear materials that are related to the corona interior, because, for example, is filled the corona interior, those are the ones that we are going to map. If you are not clear about what materials are related to the corona, just map the structures and include the corona in what we call an undifferentiated plane material. That is a unit that normally we use to mix things that we know they are there, but cannot be really differentiated with radar images because of the resolution or because the nature of the data. You are going to have like one plane unit that is going to be a bit of a mixture of things. If you can differentiate materials from that particular corona volcano, then you make a unit. If not, just the structures that are associated to the corona or to the volcano. Okay, there is another question about how to attribute the symbols. Okay, this is something that you do at the end of the exercise. For that, you need to go to the attribute table, and once you, for example, you have different lineaments and you are going to make. This is something that I think Ricardo explained the first day, and I'm sure that tomorrow that there is going to be some structural mapping on Ganymede is also going to be around. You have to map, and then after you have your fractures, or if you have a linear features or your polygons, if you are mapping the units, is when in the attribute table you are going to have the tag that is going on which you are going to divide the different structures. For example, here you can use wrinkle ridges, fractures, corona annulus, all these kind of things. Once you have the structures map and you have made this attribute table, is when you can apply the different styles to each of the attributes. So to do it, we need first to have the map. So probably just map things, and if at the end of the course you still have doubts, then I'm sure that you are going to use this for the rest of the maps. You can ask us and we can guide you again through this. But you need to first do the map, and on the attribute table is when you are going to identify the name of the units, the name of the structures, and then you can assign them to a color or to a symbol.
Thank you, Ivan. This is Ricardo. Indeed, you are right. So the very first thing to do is to construct your map, so to detect the boundaries and between the units, and then use the linear features to map the VIRTIS and the fractures or the fault lines accordingly. And once you've done that, you have categorized them in the pop-up window. Then you can assign them a name, and then afterwards, when you double click on the feature in the left table of contents, you can go to symbology and then give a symbology per category and use the attribute field, which is in this case type of structural features or unit name in the case of geological units, and then you finalize the symbology of your map, and then you can choose the proper symbol. And by the way, the videos from the first day are already up. So if you want to review anything, they are already in the dedicated page. So you can review anytime the explanation on how to attribute symbology.
Yes, and I have to say probably tomorrow we will have to deal a lot with this in Ganymede. That is also a very tectonic place.
Yes, exactly. Yeah. We will see a lot of structures and interaction between structures.
Okay, I see another doubt in the chat about where to, in a graben, where do you put the symbol between the two linear features? Yes, once you know that you have a graben, you put the symbol more or less in the middle. It's not going to make a difference because we are mapping in a very high resolution, and at the end, the cartographic products, when you make the final map, is not going to make a difference if you have it 1 centimeter to the east or to the west. But yes, the norm that we use is that we put the graben symbol between the two lineaments.
Okay, I see that most of you are having problem to extract the emissivity, to scale the emissivity values, so I can show again how to do it. I'll share my screen. So you have to make sure when you go to, 1 second. When you go to raster calculator, that you are selecting the right layer, which is this one, because we have to work with band number 1. And when you type the formula that I also paste in the chat, you have to make sure that you're using the parentheses in the right way. So I paste it here. So this should be the correct form. And here you write again the name that you want to give to the output layer. You can write again, call band 1 scale 2. And you get the layer with these values. So I see you're getting different values. So probably either you're not typing the formula in the correct way, or you are not selecting the correct band. So when you go to the raster calculator, please make sure that you are selecting this one, band number 1.
This question to show again how to attribute different planetary symbology lines to different source contacts. Yes, it's on the first day's tutorial, which is online, but I will show it anyways now, just in case you missed it, and for the sake of time. So I will take back my project on the moon of Copernicus crater, but think that it could be Venus project or Ganymede project. So in order to symbolize correctly the source contacts, one has to do this. When you are mapping, you enable the editing, you add a unit, like for example, I don't know, this contact here, and you end up editing with the right click button after you added some nodes here. you have this pop-up which is asking you the certainty. You have to populate this field with the certainty. If you do not do it, you are unable to distinguish different types of symbology, but you can choose only one because you don't give a category to this certainty field. Let's say this is fair. Okay. Now I will recompute my map. I will get a unit here because it is a closed area. You see that, for example, I have obtained another map. I don't want this, but sometimes it's good to check the mapping interface where you are working on the correct position. So if you are obtaining strange values, please go and check that you're working on the proper vector map, and in case reselect it, or you can create other ones. Now, for example, I am not getting a solution to the problem, so this map can get rid of it. You see, I can, whatever I do, if I keep in a safe place, source contacts and source indicators, everything will be fine. So to give the transparency, you double click, you go to legend, down here, opacity slider, you enable it, and then you can give the transparency. Then in your source indicators, of course, this is lacking a name at the moment, so you get this null unit. So we can give a name to this guy here. Let's select it like that, which is easier. Right click, go to the attribute table, and you see we have a unit name, which is null. We can call it, I don't know, pitted terrain or whatever. We close, we refresh, and then we will get the pitted terrain unit here. What about the symbology? So the symbology of the source contacts and on the final contacts is reflected to what you put as certainty. So the final contacts, if you open up the attribute table, they have the certainty field. I suggest you to work on the symbology on the final contacts and not on the source contacts, because the source contacts is for you to draw and to see things clearly. But if you want to symbolize, whatever you need, like source or final contacts is the same. You double click, you go to symbology here, and then you have to use this drop-down menu, which says to be not single symbol, but categorized. Yeah. If you go to categorize, you can choose a value, and the value is exactly the column of the attribute table. So in this case, the certainty. Let me resize my window. The certainty, and then nothing happens if you don't click classify. If you click classify, it will take all the columns, so the certainty, all the values inside the columns, and list them here. Okay, so let's say I add the certain contact, an inferred contact. I could have added like an interpreted contact, a subdued contact, a concealed contact. The more I add, the more records I will have here. And then to symbolize them, I click on them, I go here, and I choose on the planetary symbology here, which you should have installed this, and then this, for example, sorry, location inferred, and then I click apply. And all the contacts are correctly symbolized. And so you see, maybe it's not super clear, but this is a dashed line, and this is a full line. If you don't remember how to download the planetary symbology, which might be the case, you have to do it from the processing toolbox. You have to have installed MAPI, of course, before. You can go to processing toolbox, or to this symbol here, is the same. You click, you go to MAPI, you expand MAPI with the arrow here, then you go to mapping, and then you click here, how to download and set up mapping symbology. You double click, you click run, and the symbology is installed in your computer. And the same way, you can symbolize the linear features. The first day I showed how to trace a normal fold. Okay, let's say I would like to trace also I don't know, a fracture. Yeah, so I select the linear feature. I add a new fracture, for example. Now it's asking if it's certain, and I say certain. And the type is the type of structure: normal fault, reverse fault, Lopez scar, wrinkle ridge, graben. Maybe this can be, I don't know, wrinkle ridge. I click OK. And then I go here, double click in the symbology. I categorize by type and not by certainty in this case. And you see, now I have only normal faults, but I just added a wrinkle ridge. So I hit classify, and you will see wrinkle ridge appearing just here at the bottom. Yeah, this is not yet symbolized. So I select it, I double click, and I search for the wrinkle ridge here. Should be somewhere like well, somewhere. Anyways, I will choose a random symbol for now, like I don't know, like this. I click apply, and then I got my symbology correct. If you have this symbol, you see that the tick marks are pointing towards a specific direction that depends on the how you map the fracture. Let's say from top to bottom is putting the tick marks on the left, from bottom to top on the right. There is a way to revert this without taking care on how to map it. And this is just a trick, but maybe it can be useful. And you have to right click somewhere and add, I think it's the advanced digitizing toolbar. And there should be a button to revert the symbol. So reverse line, this one. So right click somewhere, advanced digitizing toolbar. I select the feature I want to revert, like this. And then I click this. And this should change it. Now it's not working, I don't know why. But this is one way. The other way is to map it the other way around. Anyways, we will show this again tomorrow, where we will have a lot of structure.
Thank you, Ricardo. Hello, everybody. I think that we are getting to the end of the session. For what I see, I think that we are answering all the questions in the chat. But if by any reason we miss something, just tell us, because sometimes the questions appear like disorganized. So I think that we are more or less that we have answered all of them. We hope that this has been useful for you to kick off the mapping project. Remember that we are around here to solve questions, but we will be asynchronously, so we will be answering, but be patient if we don't answer immediately, that we have other things to do. So we are still around here for some minutes, but I think that we have the coffee break in 3 minutes and the seminars after that. So we hope that you enjoy the session, that you are learning about Venus geology, and we are here for all the questions that you may have.
Thanks so much, Ivan. Thanks so much, Giulia. And yeah, that was nice. And yeah, if any question comes up, we can be in touch in the next hours and days. But I guess the participants need to spend some time and have fun on the map package.
Okay, bye-bye.
Thank you very much again.
Bye-bye. Thank you.
Bye bye. Thank you all.